There is a tooth sitting in a museum display case right now that is the size of a human hand. It belonged to a shark that was 80 feet long. That weighed 94 tons. That could open its jaws wide enough to swallow 2 adults side by side. That had a bite force researchers estimate at up to 182,000 newtons, roughly 10 times that of a great white shark. For 20 million years, nothing in the ocean could challenge it. Nothing even tried. And then, 3.6 million years ago, it was gone. Not killed, not outfought, not driven out by something bigger. It starved. The greatest predator the ocean has ever produced starved to death. And the reason it starved is the same reason it was so dominant in the first place. This is the story of how Megalodon's greatest strengths became the exact things that killed it. First, you need to understand what Megalodon actually was, because everything you've seen in movies is wrong. For most of the last century, scientists reconstructed Megalodon as essentially a giant great white shark. Same stocky body, same proportions, just scaled up to terrifying size. That image appeared in textbooks, documentaries, museum exhibits, and every Hollywood production that has ever touched the subject. A study published in March 2025 changed that picture completely. Researchers analyzed a nearly complete fossilized vertebral column, found in Belgium 11 meters of backbone alone from a single individual. By comparing its proportions against 165 species of living and extinct sharks, they determined that Megalodon's body was not stocky like a great white. It was long and slender, closer in proportion to a lemon shark, or even a large baleen whale. The revised estimate up to 24.3 meters in length, roughly 80 feet, about 2 school buses end to end, weighing approximately 94 tons, comparable to a blue whale. And here's what that size meant in practice. At that scale, a stocky body becomes a hydrodynamic disaster. The physics of moving through water at massive size demands a streamlined, elongated form. Megalodon's body wasn't just big, it was engineered for efficient movement through the ocean, capable of sustained cruising across entire ocean basins. Its newborns were already 12 to 13 feet long at birth, roughly the size of an adult great white. It's entirely possible that Megalodon pups were already hunting marine mammals within weeks of being born. This was not a large predator. This was a category of animal unto itself, and the most recent science tells us something that changes everything about how we understand this animal. Megalodon was warm-blooded. Most sharks are cold-blooded. Their body temperature matches the surrounding water. A 2023 study published in the Proceedings of the National Academy of Sciences provided the first direct empirical evidence that Megalodon was different. Researchers analyzed the chemical signature locked inside fossilized teeth using a technique called clumped isotope thermometry. The mineral apatite in teeth forms differently depending on temperature, and the isotope ratios in Megalodon's teeth showed body temperatures significantly elevated above the surrounding water. Megalodon maintained an internal body temperature warmer than the ocean it swam in, like a great white but more extreme. This was a profound evolutionary advantage. A warmer body means faster muscle response, greater swimming speed, the ability to dive into colder, deeper water while maintaining full function. It expanded Megalodon's range, increased its prey access, and likely drove the gigantism that made it the apex predator of its era. But warm-bloodedness comes with a cost that cold-blooded animals never pay: energy. An 80-foot Megalodon needed an estimated 98,000 calories per day just to maintain basic function. That's roughly 20 times what an adult great white requires. Every single day, Megalodon needed to find and consume an enormous amount of food. Not occasionally, constantly. The warm body that made it faster and more capable than anything else in the ocean also made it dependent on a steady, massive food supply in a way that cold-blooded predators simply are not. For 20 million years, that food supply existed, and then, slowly, it didn't. The world Megalodon was born into was warm, productive, and full of prey. The Miocene epoch, stretching from roughly 23 to 5 million years ago, featured higher global temperatures, higher sea levels, and warm, shallow coastal seas teeming with marine mammals. Megalodon's primary prey were baleen whales, medium-sized, abundant, and distributed across temperate and tropical waters worldwide. Megalodon's hunting strategy matched this prey perfectly. Fossil evidence shows bite patterns consistent with targeting the chest cavity, puncturing hearts and lungs to incapacitate prey quickly. It didn't need to be fast. It needed to be large, powerful, and capable of covering vast distances between feeding events. Its warm body and streamlined form made it a transoceanic hunter, migrating between feeding grounds as prey populations shifted. For millions of years, this system worked. Then, around 5 to 6 million years ago, the world began to change. Global temperatures started dropping, ice began accumulating at the poles, sea levels fell, The warm, shallow coastal seas that had served as Megalodon's nursery grounds, the waters where females gave birth and juveniles learned to hunt, began shrinking. Coastal habitat that had existed for millions of years disappeared beneath receding shorelines. The prey began changing too. The small to medium-sized baleen whales that Megalodon depended on started going extinct, replaced by larger species that were more difficult to hunt, and faster species that could evade a 94-ton predator more effectively. The distribution of remaining whale populations shifted toward polar regions' cooler waters that Megalodon's preferred temperature range made increasingly difficult to follow. The ocean was reorganizing itself, and every direction it reorganized was slightly worse for Megalodon. Then came the competitors. For most of Megalodon's reign, it had no meaningful competition at the top of the food chain. There was nothing else operating at its trophic level. It was the apex of the apex, so dominant that other large predators simply occupied different ecological niches rather than challenge it. Around 5 million years ago, that changed. The great white shark appeared. The great white was not, as was long believed, descended from Megalodon. The two lineages had diverged hundreds of millions of years earlier and evolved independently. The great white was a separate solution to the problem of apex predation, smaller, faster, more agile, and critically, cold-blooded. A 2022 study published in Nature Communications analyzed zinc isotope ratios in the fossilized teeth of both species. Zinc levels in teeth reflect an animal's position in the food chain. Apex predators show consistently lower zinc ratios. The results showed that early great white sharks occupied roughly the same trophic level as Megalodon. They were eating the same prey. For roughly 400,000 years, the two species coexisted. At first, they occupied slightly different niches, different prey size, different hunting zones. But as Megalodon's traditional prey became scarcer, those niches began to overlap. The great white, smaller and cold-blooded, needed a fraction of the calories Megalodon required. When prey was abundant, this didn't matter. When prey was shrinking, it mattered enormously. The great white could survive on less. Megalodon could not. And it wasn't just great whites. Orcas, highly intelligent, cooperative hunters operating in coordinated pods were emerging as a competing force for the same whale populations. The Megalodon that once had the ocean's prey to itself was now sharing a shrinking resource with multiple competing predators, all of them more energetically efficient. There was one more blow. Megalodon's juveniles were 12 to 13 feet long, at birth already the size of adult great whites. But juvenile megalodons and adult great whites were competing for the same food. Studies of fossil evidence suggest that great whites may have been actively preying on juvenile megalodons. The largest predator in the ocean was having its next generation targeted by a smaller, more efficient competitor. The adults were starving. The juveniles were dying. The nursery grounds were disappearing. The end came over hundreds of thousands of years, not overnight. The last confirmed Megalodon fossils date to approximately 3.6 million years ago. The disappearance wasn't a sudden event, it was a slow accumulation of pressures, each one individually survivable, collectively fatal. A warming, adapted, energy-hungry apex predator in a cooling ocean. A prey base that was shrinking and moving out of reach. Coastal nursery habitats disappearing beneath falling sea levels, a more energetically efficient competitor eating the same food, and a population of juveniles facing predation from that competitor at the most vulnerable stage of their lives. Every single one of Megalodon's defining strengths, its size, its warm body, its dependency on large prey, its coastal nursery behavior became a liability in the changing world of the Pliocene. It wasn't defeated, it was out-survived. Here's what I keep thinking about. The great white shark is often called the ocean's apex predator. It is feared, studied, protected, and placed at the top of every diagram of the marine food chain. The great white shark needs about 5,000 calories per day. It is cold-blooded, adaptable, capable of surviving on lean prey when necessary. When the ocean changes, it adjusts. Megalodon needed 98,000 calories per day. It was warm, fast, dominant, and spectacular. And it needed the ocean to keep providing at the rate it always had. The lesson the fossil record keeps teaching us is not that the biggest predator wins. It is that the most adaptable predator survives. Megalodon was the greatest predator this planet has ever produced, and it died because the ocean it had spent 20 million years perfecting itself stopped being that ocean. The teeth are still out there, washing up on beaches, sitting in museum cases, scattered across the ocean floor. The biggest ones are the size of your hand. The animal that grew them needed the world to stay the same. The world didn't.